Hi there, and a heartfelt welcome. I'm so happy you've joined me today. Before we dive in, I'd love it if you could share in the comments where in the world you're tuning in from and what time it happens to be for you right now. It's always so special to see our little community connecting across time zones. A gentle thank you as well to everyone who has already subscribed and shown love with likes on the videos. It truly makes a difference. And if you have ideas or topics you'd like me to cover, please let me know in the comments. With that, let's get started. Chapter 1. Understanding the Universe's Structure. The vast expanse of the observable universe stretches out before us, an intricate canvas painted with the light of countless stars and galaxies. Imagine standing in a serene meadow, gazing up at the night sky, each twinkling star a distant sun, each constellation a clue to the mysteries beyond our world. This observable universe, encompassing everything we can see and measure, is estimated to be about 93 billion light-years across. Yet this is just a fraction of the whole. Beyond our field of view lies the unobservable universe, a realm that remains tantalizingly out of reach, shrouded in the shadows of cosmic expansion. Cosmology, the study of the universe's origin, evolution, and eventual fate, invites us to ponder the very fabric of reality. It seeks to answer profound questions. What is the universe made of? How did it come into existence? What forces govern its expansion? These inquiries are not merely academic. They resonate with the human spirit's longing to understand our place in the cosmos. The fundamental concepts of cosmology, from the Big Bang Theory to dark matter and dark energy, offer us a framework to appreciate the universe's complexity. The term cosmology itself has ancient roots, tracing back to the Greek word cosmos, meaning order or world. As we explore the historical perspectives on the nature of the universe, we find a rich tapestry woven from the thoughts of philosophers, scientists, and dreamers. In ancient times, the cosmos was often viewed as a perfect sphere, a harmonious arrangement of celestial bodies, with Earth at its center. This geocentric model dominated for centuries, fueled by the teachings of Aristotle and Ptolemy. Yet, as the night sky continued to beckon, thinkers like Copernicus began to challenge the status quo, suggesting that the sun, rather than the Earth, held a central position. Imagine the moment when Galileo turned his telescope toward the heavens. Suddenly, the universe revealed itself in ways previously unimagined. He discovered moons orbiting Jupiter, stars that were invisible to the naked eye, and the phases of Venus, all of which supported the heliocentric model proposed by Copernicus. Galileo's observations illuminated not only the cosmos, but also the minds of those who dared to question established beliefs. As he once said, "All truths are easy to understand once they are discovered. The point is to discover them." Key discoveries continued to shape our understanding of the universe, leading us ever deeper into its mysteries. The advent of Newtonian physics provided a mathematical framework for understanding gravitational forces, allowing us to predict celestial movements with remarkable accuracy. Newton's laws of motion and universal gravitation offered a glimpse into the mechanics of the cosmos, laying the groundwork for future explorations. Then came the revolutionary insights of Albert Einstein, whose theories of relativity transformed our perception of space and time. The idea that gravity could warp the fabric of space-time itself was as mind-bending as it was profound. Imagine a trampoline, where the surface bends under the weight of a bowling ball, creating a dip. In this analogy, the bowling ball represents a massive object like a star or planet, and the dip in the trampoline simulates how space-time curves around it. Einstein's revelations not only explain the orbits of planets, but also predicted phenomena such as gravitational waves, ripples in space-time that were only recently confirmed. As we delve into the key discoveries of the 20th century, we encounter the cosmic microwave background radiation, the afterglow of the Big Bang. This faint uniform glow permeates the universe, a remnant of the fiery birth of everything we know. Discovered by Arno Penzias and Robert Wilson in the mid-20th century, this radiation provided compelling evidence for the Big Bang theory, reshaping our understanding of the universe's origins. Imagine a time when the universe was a hot, dense soup of particles, expanding and cooling, eventually leading to the formation of atoms, stars, and galaxies. The structure of the universe is not merely a collection of isolated entities. It is a grand, interconnected web of galaxies, clusters, and superclusters, all bound together by gravity. This cosmic architecture reveals patterns that hint at the underlying forces at play. The observable universe is estimated to contain over 2 trillion galaxies, each a swirling mass of stars, gas, and dust, forming intricate structures that are both beautiful and awe-inspiring. Consider the vastness of the Milky Way, our home galaxy, which is but one among many. It stretches across a realm filled with billions of stars, each potentially hosting their own systems of planets. The realization that we are part of such a grand structure evokes a sense of wonder. It invites us to ponder our significance in the cosmic scale, prompting questions about life beyond Earth. As we explore the nature of dark matter and dark energy, we find ourselves grappling with the unknown. Dark matter, an invisible substance that does not emit light or energy, is thought to make up a significant portion of the universe's mass. Its presence is inferred from its gravitational effects on visible matter. Imagine how this unseen force holds galaxies together, shaping their movements and interactions, yet remains elusive to our senses. Similarly, dark energy, a mysterious force driving the universe's accelerated expansion, challenges our understanding of cosmic dynamics. It composes a staggering 70% of the universe, yet its nature remains one of the most profound mysteries in cosmology. What is this force that pushes galaxies apart? How does it interact with the fabric of the cosmos? These questions linger, inviting us to ponder the limits of our knowledge. In the throes of exploration, we are reminded of the words of Carl Sagan, who once said, "Somewhere, something incredible is waiting to be known." This sentiment encapsulates the essence of cosmology. Each discovery, each insight, opens doors to new realms of understanding, revealing the beauty and complexity of the universe's structure. As we reflect on the historical perspectives that have shaped our comprehension of the cosmos, we see a journey marked by curiosity, perseverance, and a relentless quest for knowledge. From ancient philosophers to modern scientists, each contributed threads to the rich narrative of cosmology. Every question posed, every observation made, has brought us closer to understanding the universe's structure. Imagine the exhilaration of the first astronomers, gazing at the stars with wonder, crafting stories and theories based on their observations. They laid the groundwork for future generations, igniting a passion for exploration that continues to this day. The legacy of their inquiries lives on, echoing in the halls of modern science. With each passing year, as technology advances, so too does our capacity to explore the cosmos. Telescopes powerful enough to peer into the depths of space allow us to witness events that occurred billions of years ago. The light from distant galaxies travels across the void, carrying with it messages from the past, illuminating our present understanding. In this unfolding story of the universe, we find ourselves at a unique juncture. As we continue to unravel the complexities of the cosmos, we are reminded of our shared responsibility to honor this magnificent expanse. It is a testament to human ingenuity and the unyielding desire to reach beyond the confines of our existence. As we pause to absorb these thoughts, consider the universe not merely as a collection of galaxies and stars, but as a vast arena of possibilities. The structure of the universe is a reflection of the forces that govern it, a dance of matter and energy that has persisted for eons. Each moment in this cosmic journey is an opportunity to explore, reflect, and connect with something greater than ourselves. With every discovery, we inch closer to understanding the universe's structure and the profound truths that lie within. The questions may be daunting, but they are also a source of inspiration. As we gaze into the night sky, we are reminded that the universe is not just a backdrop to our lives. It is a living, breathing entity, offering insights and challenges that beckon us to explore further. So as we stand at the threshold of understanding, let us embrace the wonders of the cosmos, for they hold the keys to our existence and the mysteries of all that we have yet to uncover. The universe, with its unfathomable depths, is not merely a collection of celestial bodies. It is an intricate system governed by fundamental forces that shape its very existence. As we delve into the gravitational interactions that hold galaxies together, we begin to understand how these forces operate on various scales. Picture a web, each strand representing the gravitational pull of a galaxy, intertwining with others to create a complex structure that spans vast distances. The concept of gravity, first elucidated by Newton and later expanded by Einstein, serves as the cornerstone of our understanding. Gravity binds stars to galaxies, galaxies to clusters, and clusters to larger superclusters, creating a cosmic architecture that is both dynamic and resilient. It is fascinating to consider how this force, which we experience in our everyday lives, is also responsible for the majestic dance of galaxies across the universe. As we turn our gaze toward the life cycles of galaxies, we witness a narrative of creation, evolution, and eventual transformation. Galaxies are born from vast clouds of gas and dust, their formation ignited by gravitational instabilities that draw matter together. Over billions of years, these stellar nurseries evolve, giving rise to new stars and planetary systems. However, the story does not end there. Within these galaxies, violent events such as supernovae and black hole mergers act as both creators and destroyers, reshaping the very fabric of the universe. Imagine the moment when a massive star exhausts its nuclear fuel, collapsing under its own gravity. The ensuing supernova explosion disperses heavy elements into the surrounding space, seeding the cosmos with the building blocks of life. This process highlights a profound truth. The death of a star is not an end, but a new beginning, fueling the next generation of stars and planets. In the realm of cosmology, the interplay of light and matter is equally captivating. Light, traveling across the cosmos, carries with it the stories of distant worlds. The spectrum of light emitted by stars reveals their composition, temperature, and age, granting astronomers insights into the life cycles of these celestial giants. Imagine holding a prism to the light, watching as it fractures into a vivid array of colors, each hue representing a different element. This dance of light allows us to peer into the past, deciphering the history etched in the universe's glow. Key discoveries, such as the redshift of galaxies, have transformed our understanding of cosmic evolution. As Edwin Hubble observed, galaxies appear to be moving away from us, their light stretching into the red spectrum. This phenomenon implies that the universe is expanding, a revelation that has profound implications for our understanding of its structure. What does this expansion mean for the fate of the universe? Will it continue to stretch indefinitely, or will it one day contract under the weight of gravity? These questions linger, propelling us deeper into the mysteries of cosmology. The implications of an expanding universe extend to our understanding of time itself. If the universe began with a singular event, the Big Bang, then time as we know it also had a beginning. The notion that time is intertwined with the fabric of the universe invites us to reflect on our own existence within this vast continuum. Each moment is a fleeting echo, a brief flicker in the cosmic timeline. As we consider the implications of cosmic expansion, we are reminded of the words of physicist Lawrence Krauss, who said, "The amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than your right hand. It really is the most poetic thing I know about physics. You are all stardust." This poetic imagery captures the essence of our connection to the universe, reminding us that we are forged from the very elements that compose the stars. In addition to gravity and light, the cosmos is shaped by the mysterious forces of dark matter and dark energy. Dark matter, which does not interact with electromagnetic forces, remains hidden from our direct observation. However, its presence is inferred through its gravitational influence, holding galaxies and clusters together. Imagine wandering through a forest where the trees are invisible, yet you can feel their presence as you navigate through the underbrush. This is akin to our understanding of dark matter, a force felt but unseen. Conversely, dark energy propels the universe's accelerated expansion, a phenomenon that has puzzled scientists since its discovery. What fuels this enigmatic force? How does it interact with the fabric of space-time? These questions evoke a sense of wonder and challenge our understanding of the universe's fundamental nature. As we weave through these concepts, we begin to see the universe not as a static backdrop, but as a vibrant, ever-changing entity. Each discovery invites us to reevaluate our place within it. The cosmos is alive with movement, transformation, and interaction, presenting a dynamic stage where the laws of physics play out on a grand scale. The journey through cosmology is not merely an intellectual pursuit. It stirs our imagination and ignites our curiosity. Each question leads to new avenues of exploration, inspiring generations to seek answers to the profound mysteries that lie beyond our reach. As we reflect on the historical perspectives that have shaped our understanding of the universe, we witness a lineage of thinkers who dared to dream and question. They ventured into the unknown, armed with telescopes and theories, unraveling the complexities of the cosmos one insight at a time. Imagine the determination of scientists like Edwin Hubble, who, despite facing skepticism, persevered in his quest to map the universe. His legacy endures, reminding us that the pursuit of knowledge is often fraught with challenges. In this unfolding story, we find ourselves part of a continuum that stretches back through the ages, connecting us to the ancient stargazers who first looked up in wonder. As we engage with the cosmos, we become stewards of its mysteries, tasked with uncovering the truths that lie hidden within the vast expanse. Each discovery shines a light on our collective journey, encouraging us to forge ahead with hope and curiosity. The universe beckons, inviting us to explore its depths and embrace the unknown. As we stand on the precipice of understanding, let us remain open to the wonders that await us. With each question we pose, we take a step closer to revealing the intricate tapestry of existence that binds us to the stars. Chapter 2. The Big Bang, Birth of Our Universe. The Big Bang Theory stands as one of the most profound concepts in understanding our universe's origin. Envision a moment when everything we perceive, the stars, planets, galaxies, was once compressed into an infinitesimally small point, a singularity. This singularity held not just matter, but all the energy and the very fabric of space and time itself. Then, in an event that transcends our wildest imaginations, this point erupted in a colossal explosion, giving birth to the universe as we know it. Imagine the vibrant rush of energy, the symphony of creation echoing through the void. As the universe expanded, it began to cool, allowing fundamental particles to form: protons, neutrons, and electrons, the building blocks of matter. The Big Bang was not merely an explosion. It was the inception of time and space, a transition from nothingness to a cosmos brimming with possibility. What evidence supports this monumental theory? One of the most compelling is the cosmic microwave background radiation, a gentle whisper of heat that permeates the universe. This relic of the Big Bang, discovered serendipitously in the mid-20th century, is a faint glow that fills the cosmos, a remnant of the hot, dense state from which everything emerged. It is as if the universe holds onto a memory of its fiery birth, echoing back to a time when it was a mere fraction of its current size. The redshift of distant galaxies adds another layer of evidence. As Edwin Hubble first revealed, galaxies are receding from us, their light stretching into longer wavelengths, a phenomenon we recognize as redshift. This observation is akin to listening to a siren fade into the distance, a clear indication that the universe is expanding. The farther away a galaxy is, the faster it moves away, suggesting that all galaxies were once close together, supporting the notion of a singular beginning. A cornerstone of the Big Bang theory is the concept of cosmic inflation. Imagine a balloon being inflated. As it expands, the surface stretches. In the universe's case, this rapid expansion occurred just moments after the initial explosion, propelling the cosmos to unimaginable scales in a fraction of a second. This inflationary period smoothed out any irregularities, leading to the uniformity we observe today, while also creating the seeds for future structures. Galaxies and clusters formed from tiny fluctuations in density. The implications of cosmic inflation are staggering. It hints that our universe, as vast and intricate as it is, may not be the only one. The idea of a multiverse emerges, suggesting that other universes could exist, each with different physical laws, dimensions, and histories. What if we are just one thread in an infinite tapestry of existence? This concept, while tantalizing, also invites us to reflect on our uniqueness within the cosmos and the potential for realities beyond our own. As the universe continued to cool following the Big Bang, conditions became ripe for the formation of simple atoms. Hydrogen and helium emerged, the most abundant elements in the universe. These primordial atoms began to clump together under the force of gravity, paving the way for the next chapter in cosmic evolution, the formation of stars and galaxies. Picture a swirling cloud of gas collapsing under its own weight, igniting nuclear fusion at its core. This luminous birth of a star marks the next significant milestone in the universe's journey. Stars, the brilliant beacons of the night sky, serve not only as sources of light but as cosmic forges, creating heavier elements through the process of stellar nucleosynthesis. Elements like carbon, oxygen, and iron emerge from the hearts of these stars, destined to become the building blocks of planets, life, and everything we know. The life cycle of stars paints a mesmerizing picture. Some stars live for billions of years, shining brightly before reaching the end of their journey. Others, massive and mighty, undergo cataclysmic supernova explosions, scattering their enriched guts across the cosmos. This stellar debris then seeds the next generation of stars and planets. The universe, in this sense, continuously evolves, with each generation contributing to the rich complexity we observe today. As we explore the universe's evolution post-Big Bang, we also confront the forces that shape it. Dark matter, an elusive substance that does not emit light but exerts a gravitational pull, accounts for a significant portion of the universe's mass. Imagine a hidden hand guiding the dance of galaxies, influencing their formation and movement. Though invisible to our eyes, dark matter plays a crucial role in the structure of the cosmos, holding galaxies together and forming the scaffolding upon which our universe is built. Then there is dark energy, an enigmatic force driving the accelerated expansion of the universe. As galaxies race away from each other, dark energy acts like a cosmic engine, pushing the fabric of space itself apart. This reality poses profound questions. What is the ultimate fate of our universe? Will it continue to expand indefinitely, or will it one day contract? Throughout history, brilliant minds have sought to understand these mysteries. Albert Einstein once remarked, "The most incomprehensible thing about the universe is that it is comprehensible." His insights into the nature of space and time reshaped our understanding of the cosmos, setting the stage for the exploration that followed. Yet we remain only at the beginning of our journey. Each discovery opens new pathways to understanding, inviting us to reflect on our place within this grand scheme. The universe is not merely a collection of stars and galaxies. It is a dynamic, living entity, constantly evolving, filled with stories waiting to be uncovered. As we ponder the vastness of the universe, we are reminded that our existence is intertwined with these cosmic events. Each of us carries within us elements forged in the hearts of stars, a testament to our connection with the universe. We are not separate from it. We are an integral part of its ongoing story, born from the remnants of a cataclysmic event that continues to shape our reality. The Big Bang, a moment of creation, invites us to marvel at the wonder of existence. It beckons us to look up at the night sky and see not just distant stars, but the echoes of our origins, the remnants of a singularity that birthed everything. As we explore these celestial mysteries, we find ourselves not just as observers, but as participants in a cosmic journey that began billions of years ago. A journey that beckons us to dream, to question, and to understand the universe that cradles us. As the universe continued to evolve, the interplay between the forces of gravity and the primordial elements gave rise to vast cosmic structures. Imagine yourself floating in a sea of stars, witnessing the birth of galaxies. These colossal collections of stars, gas, and dust began to coalesce under the influence of gravity, forming intricate patterns that would define the large-scale structure of the universe. Galaxies come in various shapes and sizes, each a unique story in the cosmic narrative. Spiral galaxies, like our own Milky Way, feature elegant arms that spiral outward, while elliptical galaxies appear like smooth, glowing ellipsoids. Irregular galaxies, on the other hand, defy categorization, showcasing a chaotic beauty born from gravitational interactions. The formation of these galaxies is a testament to the universe's creative power, reflecting the ebb and flow of cosmic forces. Among the first galaxies to form were the so-called Population 3 stars, composed almost entirely of hydrogen and helium. These stars were massive and short-lived, burning brightly before exploding in supernovae that seeded the universe with heavier elements. The explosion of a Population 3 star would have been a breathtaking sight, a brilliant flash of light marking the end of one chapter and the beginning of another. As they exploded, they released carbon, oxygen, and nitrogen into the surrounding gas clouds, the very elements necessary for life as we know it. What happens next in this cosmic ballet? The remnants of these stellar explosions contribute to the formation of new stars and planets, creating a cycle of birth, death, and rebirth. Each generation of stars enriches the interstellar medium with heavier elements, gradually transforming the universe from a hydrogen-dominated expanse to one filled with the fundamental components of life. Consider the monumental influence of supernovae on the evolution of galaxies. As these massive stars explode, they not only spread elements across the cosmos, but also generate shock waves that compress nearby gas clouds, triggering the formation of new stars. This process illustrates the interconnectedness of the universe, where death gives rise to life in a continuous cycle, echoing the rhythms of nature we observe on Earth. As galaxies continued to form and evolve, they began to interact with one another, drawn together by gravity. Imagine the grand spectacle of galactic collisions, where two spirals meet, their stars swirling in a cosmic dance. These interactions can lead to the formation of new structures, such as galaxy clusters, which are among the largest gravitationally bound structures in the universe. They stand as testament to the dynamic nature of the cosmos, where nothing is static and everything is in a state of flux. The evolution of the universe did not stop with the formation of galaxies. Over billions of years, these galaxies merged and evolved into the rich tapestry we observe today. Some galaxies grew through the steady accumulation of gas, while others underwent dramatic mergers that reshaped their structure. Each event, large or small, contributed to the complexity of the universe. In the vastness of space, dark matter continues to hold sway, acting like an unseen architect guiding the formation of these structures. It forms a web-like network, with galaxies tracing the strands of dark matter, leading to clusters and superclusters. Imagine this network as a cosmic spider's web, where the visible galaxies are the glimmering dewdrops, each reflecting the light of distant stars. As we contemplate the universe's evolution, we must also consider the role of dark energy. This mysterious force, driving the accelerated expansion of the universe, raises profound questions about the ultimate fate of it all. Is the universe destined to expand forever, growing colder and emptier? Or could there be a time when it might reverse course, collapsing back into a singularity? In the grand scheme of things, the universe reveals itself as a dynamic entity constantly evolving and adapting. Each star that ignites, each galaxy that forms, adds layers to the story of existence, a narrative that stretches back to the very moment of creation. The universe is not merely a backdrop for our lives. It is alive, a complex web of interactions that shapes our reality. As we explore these cosmic phenomena, we cannot overlook the profound words of Carl Sagan, who once said, "The cosmos is within us. We are made of star stuff." This poetic insight encapsulates the essence of our connection to the universe. Every element in our bodies was forged in the hearts of stars, linking our existence to the cosmic events that unfolded long before our planet came to be. In reflecting on our origins, we are invited to ponder the deeper implications of our existence. What does it mean to be a part of this grand universe, born from the remnants of ancient stars? Each moment in our lives is a continuation of cosmic history, a story written in the language of atoms and energy, bound by the forces of nature. As we embrace this understanding, we find serenity in the knowledge that we are not alone in our quest for meaning. The universe is a vast, collaborative endeavor where each of us plays a role in the unfolding drama of existence. We are witnesses to an extraordinary journey, a journey that began with the Big Bang and continues to this day. In the stillness of the night, as we gaze up at the stars twinkling in the velvet sky, we can feel the pulse of the universe. Each star shines with the light of a million stories, each galaxy a testament to the grandeur of creation. We are, in essence, stardust contemplating the stars, part of a magnificent cosmic cycle that invites us to dream, to explore, and to seek understanding in the mysteries that surround us. The universe, in its infinite complexity, offers us not just answers, but a canvas for our imagination. As we delve into its depths, we uncover not only the mechanics of celestial bodies, but also the profound beauty that lies in the interconnections of all things. Each discovery leads us further along this path, illuminating our understanding and deepening our appreciation for the cosmos we inhabit. Chapter 3. Exploring the concept of multiverses. The concept of multiverses invites us to expand our understanding of reality beyond the confines of our observable universe. Imagine a vast expanse where not just one universe exists, but potentially an infinite number of them, each with its own unique characteristics and laws of physics. The origins of multiverse theory can be traced to early discussions in cosmology, where thinkers began to ponder the implications of an ever-expanding universe. As we have seen, the Big Bang marked the birth of our universe, setting off a chain of events that led to the formation of galaxies, stars, and planets. Yet the question arises, what if this is merely one chapter in a much larger saga? Multiverse theory suggests that our universe is just one bubble in a frothy sea of universes. This idea can be daunting yet exhilarating. Philosophers and scientists have long debated the nature of reality, and the notion of multiple universes challenges our conventional understanding. If each universe is governed by different physical laws, what does that mean for the concept of existence itself? There are several intriguing models of the multiverse that have emerged over the years, each offering a different perspective on how these parallel realities could operate. One of the most well-known is the cosmic inflation model proposed by Alan Guth. This theory posits that in the moments following the Big Bang, the universe underwent an exponential expansion. In this scenario, different regions of space could stop inflating at different times, leading to the creation of isolated pocket universes, each with its own distinct properties. Imagine these pockets as bubbles in a vast cosmic foam, each one a universe unto itself. Some may resemble our own, while others could be so radically different that they challenge our very notions of matter and energy. In some of these universes, the fundamental forces of nature might operate under entirely different rules. What if gravity were weaker or non-existent in another universe? Would life as we know it even be possible? Another fascinating model is the many worlds interpretation of quantum mechanics, popularized by physicist Hugh Everett. This interpretation suggests that every quantum event could lead to the branching of universes, creating multiple outcomes for every possible scenario. Picture a diver standing at a fork in the road. Each choice they make leads to a different path, creating a new universe for each decision. In one universe, the diver chooses to go left, while in another, they go right. This model raises profound questions about free will and the nature of choices. Now, consider the implications of embracing a multiverse perspective. If multiple universes exist, what does that mean for our understanding of existence? It suggests that the universe we inhabit is only a small fragment of a much grander reality. This notion evokes a sense of wonder and curiosity. Can we find meaning in our lives knowing that countless versions of ourselves might exist in parallel realities? The contributions of key physicists have shaped the landscape of multiverse theory, each adding threads to this complex web of ideas. One of the most influential voices in this field is Max Tegmark, who proposed a classification system for different types of multiverses, ranging from Level 1 universes, which are simply regions beyond our observable universe, to Level 4 universes, which encompass all mathematical structures. Tegmark's work encourages us to think about the universe not just in physical terms, but in mathematical ones as well. Stephen Hawking also contributed significantly to our understanding of the multiverse, particularly through his explorations of black holes and their relationship with quantum mechanics. Hawking famously stated, "The universe doesn't have just one history, it has many." His insights invite us to ponder the nature of time and existence within a multiverse framework. As we explore these concepts, we might ask ourselves, how do we reconcile the idea of multiple universes with our personal experiences? Each individual life feels unique and significant, yet multiverse theory suggests that there are endless variations of our experiences playing out simultaneously. This duality can be comforting. It reminds us that we are part of something larger, a cosmic dance of possibilities where every choice creates a ripple effect across numerous realities. The philosophical implications are profound. Within a multiverse, the questions of purpose and significance can be re-examined. If every conceivable outcome is realized in some universe, does that diminish our experiences here? Or does it enhance them, suggesting that every moment is precious precisely because it is one of countless possibilities? What lies at the heart of these theories is a deep-seated curiosity about our place in the cosmos. Multiverse theory challenges us to think beyond the limitations of our own universe to imagine a reality that extends far beyond our comprehension. It encourages a spirit of exploration and wonder, inviting us to ponder the mysteries that lie beyond the stars. As we consider the vast array of possibilities offered by multiverse theory, we can't help but reflect on our desires for connection and understanding. Each universe is a mirror reflecting different facets of existence, and in contemplating these realms, we embrace the complexity of being. In a world where the multiverse exists, the very fabric of reality becomes an intricate quilt, stitched together by the threads of possibility and probability. Each thread represents a unique universe, with its own story waiting to be told. The allure of the multiverse is not merely in its scientific implications, but also in its ability to inspire creativity and imagination. It opens the door to countless stories yet to unfold, allowing us to envision worlds where anything is possible. Perhaps there exists a universe where our wildest dreams have already come to fruition, or where history has taken a dramatically different turn. As we reflect on these ideas, we can draw inspiration from the words of physicist Brian Greene, who eloquently stated, "The multiverse is a beautiful idea that captures the essence of human imagination." In this light, the exploration of multiverses becomes not just a scientific endeavor, but a journey into the depths of human creativity and aspiration. As we delve deeper into the multiverse, we begin to see that our understanding of reality is continuously evolving. The more we learn about the universe, the more questions arise, each one leading us down new paths of inquiry. The multiverse invites us to consider the very nature of existence, sparking our curiosity and fueling our desire to explore the unknown. In pondering the vastness of the multiverse, we are reminded of the beauty and complexity of the cosmos. Every star, every galaxy, every universe carries a story, a history waiting to be discovered. As we continue our exploration of these ideas, we open ourselves to the wonder that lies beyond our own universe, embracing the infinite possibilities that await us in the realms of the multiverse. What if the universe we know is merely a stepping stone toward understanding a greater reality? The journey is one of awe and contemplation, a chance to reflect on our place in the cosmos and the myriad stories that intertwine with our own. As we proceed, let us keep our minds and hearts open to the endless possibilities that the multiverse presents, inviting us to dream, explore, and discover the wonders that await in the fabric of existence itself. As we immerse ourselves in the vastness of multiverse theory, we begin to appreciate the potential implications it holds for our understanding of reality. The idea that our universe is merely one of many raises questions about the very nature of existence. What if the laws that govern our universe are just one set among an infinite array? This perspective not only broadens our horizon, but also invites us to reconsider the very fabric of reality itself. One intriguing model that captures the imagination is the string theory multiverse. This approach suggests that at the most fundamental level, the universe is composed of tiny vibrating strings. These strings, much like the strings of a musical instrument, can vibrate in different ways, giving rise to the various particles and forces we observe. In this framework, multiple dimensions beyond the familiar three of space and one of time come into play. Imagine a reality where the universe exists in 10 or even 11 dimensions, with each additional dimension providing a different avenue for the strings to vibrate. The implications of such a structure are profound. It suggests that variations in the way these strings vibrate could lead to entirely different physical laws, resulting in diverse universes, each with unique properties. Consider the words of physicist Leonard Susskind, who remarked, "The multiverse is a consequence of string theory." This statement encapsulates the essence of how string theory intertwines with multiverse concepts, illustrating how theoretical frameworks can expand our comprehension of what's possible in the cosmos. Another captivating model is the landscape multiverse, which emerges from string theory. In this model, the multitude of possible vacuum states of string theory can lead to a vast number of distinct universes. Picture a vast landscape of hills and valleys, where each peak represents a different universe with its own unique configuration of physical laws. The landscape multiverse suggests that our universe is just one valley, nestled among countless others. Each of these valleys could harbor different constants and forces, leading to fundamentally different experiences of reality. Imagine the possibilities. In one valley, the laws of physics might allow for the existence of life as we know it, while in another, the very conditions might render life impossible. The landscape multiverse challenges our assumptions about what constitutes existence, urging us to think beyond the boundaries of our own experiences and consider the rich diversity of life and matter that may exist across different realms. As we reflect on these theories, we cannot help but ask ourselves about the interconnectedness of these universes. Are they completely isolated? Or could there be some form of interaction between them? The idea of universes influencing one another opens up a new realm of inquiry. What if the choices we make in this universe ripple across others? This notion of interconnected realities adds a layer of complexity to our understanding of causality and existence. The implications of multiverse theory extend far beyond science. They touch on philosophy, ethics, and even spirituality. If every possibility exists across the multitude of universes, how does that shape our understanding of morality and free will? Some may find solace in the idea that every choice they make has a counterpart in another universe, where a different path was taken. Does this notion empower us, or does it create a sense of detachment from our decisions? The contributions of physicists who have shaped multiverse theory remind us of the deep human desire to understand our place in the cosmos. Notable figures such as André Linde have furthered the discussion through their work on chaotic inflation, positing that the universe could be eternally inflating, creating an endless number of universes. This perspective aligns with the ever-expanding nature of our own universe, reinforcing the idea that what we see is just a fleeting glimpse of a much larger reality. Think about the implications of an eternally inflating universe. Every moment, new universes could be born, each with its own unique characteristics. This endless cycle of creation invites us to reflect on the nature of time itself. If time is but a dimension among many, how do we measure the significance of each moment? As we delve into these profound questions, the voices of those who have explored the boundaries of our understanding echo through our thoughts. Theoretical physicist Sean Carroll once stated, "The multiverse is a natural consequence of the laws of physics." This sentiment emphasizes that the exploration of multiverses is not merely an abstract exercise, but a logical extension of our scientific inquiries. In contemplating the multiverse, we come to understand that the act of exploration is as vital as the discoveries themselves. Each theory, each model, serves as a stepping stone toward a deeper understanding of the universe. The quest to uncover the mysteries of existence is a journey that transcends the confines of our own reality, inviting us to embrace the wonder that lies beyond. As we navigate through these concepts, we can find a sense of peace in the vastness of possibilities. The multiverse invites us to reconsider our place within the cosmos, inspiring a sense of connection to the countless stories unfolding in parallel realities. Each universe exists as a testament to the myriad ways existence can manifest, offering us a chance to reflect on the beauty of the unknown. Contemplating the multiverse not only enriches our understanding of science, but also our appreciation for the mysteries that life presents. It encourages us to remain curious, to embrace the complexity of the cosmos with open hearts and minds. As we continue on this journey of exploration, let us hold space for the wonder and awe that the multiverse inspires, deepening our connection to the universe and to each other. Chapter 4. Quantum Mechanics and Parallel Universes. Quantum mechanics, the branch of physics that delves into the behavior of matter and energy at the smallest scales, invites us to consider a realm where the familiar rules of reality seem to dissolve. Picture a world where particles exist in a state of probability, where their very existence is influenced by the act of observation. This is the essence of quantum mechanics, a field that challenges our understanding of reality itself. As we explore this fascinating territory, consider the implications of a reality that is not fixed, but rather fluid and interconnected in ways we have yet to fully comprehend. At the heart of quantum mechanics lies the principle of superposition. Imagine a spinning coin, perfectly balanced between heads and tails until it lands. In the quantum world, particles can exist in multiple states simultaneously, like that coin caught in its dizzying spin. This idea is beautifully illustrated by the thought experiment known as Schrödinger's cat, where a cat in a sealed box can be both alive and dead until someone opens the box to observe it. This paradox highlights the strangeness of quantum behavior, where reality is not simply what we see, but rather a complex interplay of possibilities. The many worlds interpretation, proposed by physicist Hugh Everett, takes this concept even further. It suggests that every quantum event branches into a multitude of alternate realities. Imagine each decision you make creating a new universe where different outcomes unfold. If you choose to go left, there exists a universe where you went right. This interpretation paints a picture of an ever-expanding multiverse, where every possible outcome is realized in its own distinct universe. Everett's groundbreaking theory invites us to ponder, what does it mean for our understanding of choice and fate? Each decision we face could give rise to a cascade of realities, each with its narrative, each equally valid in its existence. Consider now the implications of quantum events creating alternate realities. When subatomic particles interact, they can lead to outcomes that feel random and unpredictable. But in the many worlds framework, these interactions are not merely random. They are the seeds of new universes. Imagine a cosmic web, with each thread representing a different reality, branching out from the choices made at the quantum level. The very act of observing a particle can collapse its wave function, determining its state in one universe while simultaneously giving birth to an infinite number of others. This challenges our conventional understanding of causality and time, suggesting that our experiences are but a single thread in an intricate weave of existence. As we contemplate these ideas, we might ask ourselves about the philosophical implications of quantum multiverses. If every possibility is played out in some universe, what does that say about our own lives? Are our choices as significant as we believe them to be? The existence of parallel universes brings forth questions of identity and reality. Are we defined solely by our experiences, or do we exist in multiple forms across different realities? This view can be both liberating and daunting, as it opens the door to an infinite tapestry of existence, where every what if becomes a reality in its own right. The notion of parallel universes also interacts with the fabric of time. Imagine time not as a linear path, but as a vast, branching tree, where every moment can lead to countless potential futures. Each decision, each moment of uncertainty, creates new branches that extend into the unknown. This perspective offers a profound shift in how we perceive our lives and the universe. If every choice creates a new branch of reality, then every moment is a gateway to a multitude of experiences, each waiting to be explored. Renowned physicist David Deutsch eloquently articulated this idea when he stated, "The multiverse is a vast, infinite realm of possibilities." His words resonate with the essence of quantum mechanics and the many worlds interpretation, urging us to embrace the complexity of our existence. It invites us to not only marvel at the intricate nature of the universe, but also to reflect on our place within it. Are we mere observers or active participants in the unfolding of countless realities? As we continue to explore the implications of quantum mechanics and the existence of parallel universes, we might envision the vastness of our own universe as merely one of many. Imagine standing on a shore, gazing out at an endless ocean, each wave representing a different universe, each one shaped by the quantum events that have transpired. This imagery evokes a sense of wonder and curiosity, prompting us to ponder the mysteries that lie beyond our immediate perception. The philosophical dimensions of this multiversal perspective challenge us to rethink our understanding of existence. If every choice leads to a different reality, what does that mean for concepts such as destiny and free will? The interplay of choice and consequence becomes infinitely more complex in a multiverse where every possibility manifests. We are left to wonder, does this diminish the significance of our decisions? Or does it amplify them, knowing that each choice crafts a new narrative in the grand saga of existence? Moreover, the implications extend beyond the individual to society as a whole. In a universe where countless realities coexist, we may begin to understand differing perspectives and experiences with greater empathy. Each person might be seen as a traveler navigating their own unique path among the infinite options available, shaped by their choices and experiences. This realization fosters a deeper connection to others, as we recognize that while our realities may diverge, we are all part of the same cosmic fabric. As we delve into these profound concepts, we can find solace in the idea that the universe is vast and full of potential. The many worlds interpretation offers a comforting notion that no possibility is lost. Every moment of choice is a doorway to new experiences, new realities. It encourages us to embrace uncertainty and to find beauty in the unknown. Imagine drifting through a garden of possibilities, each flower representing a different outcome, each one unique and vibrant in its own right. In this expansive landscape of quantum mechanics and parallel universes, we stand at the threshold of profound understanding. The principles that govern the smallest particles also ripple through our lives, influencing the very essence of our existence. This interconnectedness offers a sense of purpose, inviting us to explore the nature of reality and our role within it. The journey of discovery is not merely intellectual. It is an exploration of the self, an invitation to contemplate who we are in a universe that is far more complex and beautiful than we can fully grasp. As the mysteries of quantum mechanics unfold, we find ourselves continually drawn to the question, what lies beyond the known? The potential of alternate realities beckons us to remain curious, to explore the depths of existence with open hearts and minds. In this vast expanse of possibilities, we may discover not only the intricacies of the universe, but also a deeper understanding of ourselves and our place in the grand narrative of existence. The exploration of quantum mechanics, particularly through the lens of the many worlds interpretation, brings us to consider the intricate relationship between consciousness and reality. Imagine how our very act of perceiving the world could be a catalyst for branching realities. When we observe a quantum event, we do not merely witness a singular outcome. We inadvertently shape the cosmos itself. This leads us to ponder, how does awareness intertwine with the fabric of existence? Renowned physicist Max Tegmark has suggested that consciousness itself may be a phenomenon that transcends our typical understanding, interwoven with the multiverse concept. He posits that consciousness is not just in our brains, but is a fundamental aspect of the universe. This idea opens a door to the possibility that our thoughts, our awareness, and our very essence could ripple through the many branches of reality, influencing them in ways we have yet to fully comprehend. As we engage with these profound ideas, it becomes crucial to consider the implications for our understanding of free will. If every decision propels us into a different universe, what does this mean for our sense of agency? Are we the architects of our destinies, or are we merely players in an elaborate cosmic play? The notion of choice takes on a kaleidoscopic quality, where every decision is but one thread in an infinite loom of potential outcomes. Imagine standing at a crossroads, with paths unfurling before you, each leading to a unique reality. The weight of your choices feels immense, yet in the multiversal framework, every path you could take exists simultaneously in its own universe, each filled with a distinct set of experiences and consequences. This perspective allows us to embrace the complexity of our lives, revealing that while we may feel bound by our decisions, we are also granted the freedom to explore countless narratives across the multiverse. Such a viewpoint encourages us to cultivate a sense of curiosity and openness toward our life experiences. Instead of viewing past decisions as fixed points, we can understand them as part of a larger continuum, where each choice has led to new possibilities. This invites a sense of forgiveness for ourselves as we recognize that every outcome is simply a reflection of one possible path taken among many. In contemplating the philosophical ramifications of the many worlds interpretation, we can also reflect on the nature of identity. If we exist in multiple realities, does that mean we are multifaceted beings, shaped by the myriad choices we could have made? Each version of ourselves carries the weight of a different life, a different set of experiences. This notion invites a broader understanding of empathy, as we recognize that everyone is navigating their own unique set of circumstances in their respective universes. As we further engage with these themes, we might ask, how does this awareness of parallel existences impact our relationships and interactions with others? If we acknowledge that every individual is a culmination of diverse choices and experiences, we can foster deeper connections. Each conversation becomes not just an exchange of words, but a meeting of multiple realities, rich with the potential for understanding and growth. The interplay of quantum mechanics and the multiverse does not merely reside in the realm of theoretical physics. It invites us to examine our place in the universe more intimately. Each moment, each decision holds the potential for creating new branches of existence, and within this lies an immense beauty. Imagine embracing the uncertainty of life, knowing that every choice you make can lead to a vibrant array of possibilities. This perspective encourages us to approach the unknown with a sense of wonder rather than fear. As we contemplate the vastness of the multiverse, we might visualize it as a grand cosmic tree, its branches stretching infinitely in every direction. Each branch represents a different reality, each leaf a unique choice leading to distinct experiences. This image evokes a sense of peace, reminding us that while our lives may feel constrained by circumstances, the potential for exploration and growth is boundless. The journey through quantum mechanics and the many worlds interpretation teaches us about the fluidity of reality and the interconnectedness of our choices. In a universe governed by uncertainty, we are invited to embrace the unknown, to dance with possibility, and to affirm our place as co-creators of our existence. Each moment is a canvas upon which we paint our lives, and through our choices, we contribute to the ever-expanding narrative of the cosmos. In this context, we can appreciate the profound significance of our daily lives. The mundane becomes extraordinary when viewed through the prism of infinite possibilities. The simple act of waking up in the morning transforms into an opportunity to explore the vast expanse of realities that lie ahead. How might we approach our day differently if we understood that each decision could lead us into a new universe filled with unique experiences? As we continue to unravel the mysteries of quantum mechanics and the parallel universes that may exist, we find ourselves at the intersection of science and philosophy. This intersection offers a fertile ground for exploration, encouraging us to question the very nature of reality and our role within it. Are we passive observers or are we active participants in the grand unfolding of existence? The answers to these questions may not be definitive, but the journey of inquiry itself is what enriches our understanding of the cosmos and our place within it. This rich tapestry of thought invites us to remain curious, to engage with the unknown, and to embrace the infinite possibilities that lie before us. Each moment is a gift, a chance to explore the boundless realms of existence, where every choice shapes not only our individual journeys, but also the collective narrative of the universe. As we navigate this intricate landscape, we may find that the essence of life is not merely in the outcomes we achieve, but in the exploration of the vast, interconnected web of realities that awaits us. Chapter 5: Cosmic Inflation, Gateway to Multiple Universes. Imagine standing on the edge of a vast ocean, the waves shimmering under the starlit sky. Each crest and trough tells a story of the universe's creation, a narrative that begins with the Big Bang and flows into the realm of cosmic inflation. This inflationary universe model is a captivating chapter in our understanding of the cosmos, presenting a vision where our universe expanded exponentially in a fraction of a second after the initial explosion. Picture a balloon being inflated. As the air rushes in, the surface stretches and expands dramatically, much like the universe did during this early phase. The inflationary model proposes that our universe underwent a period of rapid expansion, stretching out the fabric of space-time itself. This expansion smoothed out the initial irregularities, creating the homogeneous and isotropic universe we observe today. It is as if the universe took a deep breath, inflating into existence, leading to the myriad of structures we see today, from galaxies to cosmic filaments. But how does this rapid inflation relate to the tantalizing idea of multiple universes? As we ponder this question, we enter a realm where the possibilities multiply. The inflationary model suggests that different regions of space could inflate at different rates, leading to the creation of bubble universes. Each bubble could represent a separate universe, with its own distinct properties and physical laws. Imagine a cosmic garden, where each universe blooms with its unique characteristics, some flourishing under different constants of nature, while others might harbor entirely different forms of matter and energy. The notion that inflation could give rise to multiple universes resonates deeply with the multiverse theory we touched upon earlier. If our universe is but one bubble in a vast cosmic sea, how does this change our understanding of existence? The very concept challenges our perception of reality, pushing the boundaries of what we consider possible. As physicist Alan Guth, one of the pioneers of inflationary theory, stated, "The very early universe was not only expanding, but it was also doing something very different. It was generating new space." This idea invites us to imagine not just infinite possibilities within our universe, but an entire cosmos of universes, each a unique narrative unfolding across the vastness of existence. As we explore the evidence supporting cosmic inflation, we find ourselves navigating a landscape rich with discoveries. The cosmic microwave background radiation, that soft whisper echoing through the universe, reveals imprints of the inflationary period. Tiny fluctuations in temperature across this background radiation are remnants of the quantum fluctuations that occurred during inflation. These fluctuations are like ripples on a pond, capturing the essence of the early universe's chaotic yet orderly expansion. Observations from advanced telescopes and satellites have provided further insights into this primordial soup. The Planck satellite, for instance, has mapped the cosmic microwave background with astounding precision, revealing a universe that is remarkably uniform on large scales, yet exhibits slight variations that hint at the inflationary process. Such evidence not only supports the inflationary model, but also adds depth to our understanding of how the universe's structures formed over billions of years. Yet, as with any grand theory, challenges and critiques emerge from the shadows. Some scientists question the inflationary model's assumptions, particularly the idea that inflation could occur smoothly and uniformly. Detractors argue that the model relies on specific conditions that may not be universally applicable. They raise the question, if inflation can lead to multiple universes, what then governs their existence? Is there a mechanism that ensures these universes have the diverse characteristics proposed? Or do we simply lack the tools to observe them? Another point of contention lies in the testability of inflationary predictions. Scientific theories thrive on verification through observation and experimentation. While some aspects of inflation have been supported by data, the idea of multiple universes remains elusive. How can we confirm the existence of universes beyond our observable realm? This uncertainty can sow doubt among skeptics, leading to debates that stir the very foundations of cosmology. Despite these challenges, the allure of cosmic inflation and the possibility of multiple universes continues to captivate minds across the globe. It invites a sense of wonder and imagination, as if we stand on the precipice of understanding something greater than ourselves. What if our universe is merely one of countless others, each with its own story, each contributing to the grand narrative of existence? As we contemplate these ideas, we are reminded of the profound words of physicist Max Tegmark, who articulated, "The multiverse is a natural consequence of the laws of physics." Each universe, a unique expression of these laws, invites us to ponder the nature of reality itself. Imagine gazing into the cosmos, feeling as if the stars are not just distant points of light, but gateways to other realms. The vastness of space becomes not just an expanse but a canvas upon which the multiverse paints its intricate designs. The concept of inflation serves as a bridge, linking the singular moment of the Big Bang to the infinite possibilities that lie beyond our perception. In this journey through the cosmos, we have glimpsed the potential for universes that challenge our understanding of life, existence, and reality. Each universe may tell a different story, one that reflects the myriad ways in which physical laws can manifest. What if, in some distant universe, the laws of gravity are reversed? Or what if life has evolved in forms we cannot even begin to imagine? The exploration of cosmic inflation and the birth of multiple universes stretches our minds, encouraging us to think beyond the confines of our own experience. It beckons us to consider the immense possibilities that emerge from the simplest beginnings. As we drift through these thoughts, we find ourselves at the intersection of science and philosophy, where questions linger and answers await discovery. In this vast interplay of ideas, there is a soothing rhythm, a reminder that the quest for knowledge is as significant as the knowledge itself. The universe, in all its complexity, invites us to embrace the unknown, to seek understanding in the face of uncertainty, and to marvel at the beauty of existence, whether within our universe or beyond it. As we continue this journey through the cosmos, let us remain open to the wonders that await, for in the heart of these ideas lies not just the story of our universe, but the essence of curiosity that drives us to explore the very fabric of reality. As we turn our attention to the evidence supporting cosmic inflation, we encounter an array of discoveries that illuminate this fascinating concept. The cosmic microwave background radiation serves as a cornerstone of this evidence, a faint glow that fills the universe, providing us with a snapshot of the infant cosmos. These minuscule temperature fluctuations, remnants of the early universe, are akin to echoes of a symphony, each note telling the story of the universe's birth. They reveal not only the uniformity of the cosmos, but also the slight irregularities that arose during inflation, laying the groundwork for the large-scale structures we observe today. Imagine these temperature variations as a cosmic fingerprint, unique to our universe, and yet part of a much larger narrative. Advanced telescopes and satellite missions, such as the Planck satellite, have meticulously mapped this radiation, uncovering the intricate details of our universe's infancy. The data collected has further validated the inflationary model by showing how these fluctuations correlate with the distribution of galaxies across the cosmos. Each galaxy is a cluster of stars, gas, and dust, forged from the primordial chaos of the early universe, a testament to the processes initiated during that brief moment of inflation. Yet the journey into cosmic inflation is not without its challenges. The inflationary theory, while compelling, faces scrutiny and skepticism from various corners of the scientific community. One significant critique revolves around the model's inherent assumptions. Critics argue that the conditions necessary for inflation to unfold smoothly may not be universally applicable. They pose questions that resonate through the halls of scientific inquiry. What if the inflationary process was not as uniform as proposed? What if certain regions of space inflated at unpredictable rates, leading to a chaotic landscape of universes? Furthermore, the testability of inflationary predictions adds another layer of complexity. Science thrives on the ability to observe and verify theories through empirical evidence. While we have gathered substantial data supporting inflation, the idea of multiple universes remains tantalizingly out of reach. How do we confirm the existence of universes that lie beyond our cosmic horizon? This uncertainty can foster doubt, leading to spirited debates that challenge the very foundation of our understanding. Despite these critiques, the allure of cosmic inflation and the multiverse it suggests continues to inspire awe. It invites us to stretch our imaginations and contemplate the profound implications of existence itself. What if our universe is just one thread in a vast cosmic quilt, each thread representing a unique universe, woven together by the laws of physics? As we ponder these ideas, we are reminded of the words of physicist Brian Greene, who eloquently expressed the wonder of such possibilities. The universe is a tapestry that is woven of the same fabric as our very thoughts, ideas, and dreams. Such reflections urge us to consider the interconnectedness of all things, where the boundaries of our understanding expand beyond the observable, inviting us into the realms of imagination and speculation. Imagine gazing into the night sky, each star a potential gateway to another universe, each constellation a map to realms yet unseen. This perspective transforms the cosmos from a mere backdrop to our existence into a dynamic stage, brimming with stories waiting to be told. The inflationary model not only bridges the moment of the Big Bang to the vast universe we inhabit, but it also opens the door to countless other realities, each a unique manifestation of physical laws. As we explore this tapestry of possibilities, we must also consider the philosophical implications of the multiverse. If multiple universes exist, what does that mean for the nature of our reality? Are we mere observers in a grand play, or do we hold a more profound role in shaping the outcome of our universe? This contemplation leads us to the heart of existential questions that have intrigued humanity for centuries. The interplay between science and philosophy enriches our understanding of cosmic inflation and the multiverse. It invites us to seek not only knowledge but also wisdom as we grapple with the intricacies of existence. What if the nature of reality is more fluid than we imagine, where every decision we make ripples through the fabric of the cosmos, potentially influencing the birth of new universes? As we navigate these thoughts, we find ourselves at the intersection of curiosity and wonder, where the quest for knowledge becomes a journey of self-discovery. The universe, with its mysteries and enigmas, beckons us to embrace the unknown and seek understanding in the face of uncertainty. In this expansive landscape of ideas, we are reminded that the universe is not a static entity but a dynamic, ever-evolving story. Each moment unfolds new possibilities, and as we continue to explore the implications of cosmic inflation and multiple universes, we are invited to reflect on our place within this grand narrative. What stories lie ahead in the cosmic expanse? What wonders await our discovery as we forge deeper into the mysteries of existence? The answers may not be readily available, but the journey itself is a testament to our unyielding pursuit of knowledge and meaning amidst the vastness of the cosmos. As we drift through these contemplations, let us remain open to the infinite possibilities that emerge from the interplay of science and imagination. The universe, in all its complexity, offers us not just a glimpse into its workings, but a profound invitation to explore the depths of our own existence. Each question we ask, each idea we ponder, adds another layer to the rich tapestry of understanding, drawing us closer to the heart of the cosmos. Chapter 6. String Theory and Dimensions Beyond the Observable. In the vast and intricate landscape of theoretical physics, string theory emerges as a captivating framework, one that seeks to unite the forces of nature in a harmonious melody. Imagine a world where the fundamental particles of the universe are not mere points, but rather tiny, vibrating strings. Each string, minuscule in scale, oscillates in a symphony of frequencies, with each vibration corresponding to a different particle. This musical theory proposes that the characteristics of particles, such as mass and charge, are determined by the way these strings vibrate. As we paint this picture, it is essential to understand that string theory is not just a whimsical idea, it is a serious contender in the quest for a unified theory of everything. It attempts to meld the principles of quantum mechanics, which governs the behavior of the smallest particles, with the elegance of general relativity, which describes gravity and the curvature of space-time. The potential of string theory lies in its promise to explain the fundamental nature of the universe in a singular framework, offering a glimpse into the underlying structure that binds all matter and energy together. One of the most intriguing aspects of string theory is the concept of additional dimensions. While we experience our universe in 3 dimensions of space and 1 of time, string theory suggests that there could be many more dimensions, possibly up to 10 or even 11. Imagine a garden with flowers blooming in surprising colors, hidden pathways leading to undiscovered realms. These extra dimensions are compactified, wrapped up so tightly that they elude our direct observation. What might these additional dimensions look like? They could be like tiny loops or complex shapes, known mathematically as Calabi-Yau manifolds. These shapes are not merely abstract. They hold the key to understanding the universe's properties. As the strings vibrate in these extra dimensions, they give rise to the physical phenomena we observe in our familiar 4-dimensional world. The beauty of this idea lies in its ability to expand our comprehension of reality, suggesting a universe that is infinitely richer and more complex than we can perceive. As we ponder the implications of string theory, it becomes clear that it aligns with the notions of multiverses we explored previously. In the context of string theory, each universe could have its own distinct configuration of dimensions and physical laws. Picture a vast library, where each book represents a different universe, each with its own unique story to tell. In this grand multiverse, the variations in string vibrations could lead to diverse realities, some perhaps resembling our own, while others may be entirely alien. The journey into the depths of string theory is not without its challenges. Despite the elegance of its mathematics and the allure of its implications, the theory remains largely untested. One of the fundamental issues is the difficulty in obtaining experimental evidence. The strings are so small that current technology cannot directly measure their effects. The energy scales required to probe these dimensions lie far beyond the reach of our most powerful particle accelerators. Yet, the scientific community is not deterred. Physicists continue to explore the consequences of string theory, searching for signatures that could provide evidence for its validity. Some researchers are investigating the implications of string theory in cosmology, exploring how the early universe's inflationary period could be influenced by string dynamics. Others are delving into the mathematical framework of the theory itself, looking for new insights that could bridge the gap between theoretical predictions and experimental observations. As we reflect on these challenges, we can appreciate the resilience of human curiosity. The pursuit of knowledge, the desire to understand the universe's intricacies, drives researchers to probe deeper into the unknown. String theory, with its promise of additional dimensions and the potential for a multiverse, invites us to dream of a reality beyond our current understanding. Imagine if we could glimpse into these hidden dimensions. What wonders might we find? Perhaps new forces or interactions that govern the behavior of particles, or even entirely new realms of existence. The possibilities spark the imagination, fueling the quest for discovery and understanding. In this landscape of theoretical exploration, the words of physicist Brian Greene resonate deeply. The universe is a symphony of strings, and the notes are the particles that make up everything we see. As we stand at the threshold of knowledge, the music of the cosmos beckons us to listen closely. String theory, with its foundations rooted in the quest for unification, challenges us to envision the universe in new and profound ways. It invites us to stretch the boundaries of our understanding, to explore the interplay between dimensions, and to embrace the complexity of existence. In doing so, we not only seek answers but also cultivate a sense of wonder about the universe we inhabit. As the narrative unfolds, the dialogue of science continues, weaving together ideas from various fields, much like the strings themselves intertwining in an elegant dance. The exploration of string theory and its implications echoes the sentiments of those who came before us, who, in their own ways, sought to unravel the mysteries of the cosmos. In this ongoing journey, we find ourselves standing on the shoulders of giants, physicists like Edward Witten and Michio Kaku, who have contributed significantly to the development of this fascinating theory. Their insights and discoveries inspire new generations to pursue the elusive truths of the universe. The realm of string theory remains an exciting frontier where questions abound and answers are always just out of reach. As we continue to explore, we must remain patient and resilient, embracing the uncertainty that accompanies the quest for knowledge. Each step forward, whether through theoretical advancements or experimental breakthroughs, brings us closer to unraveling the cosmic tapestry that envelops us. As we venture further into the depths of string theory, we also encounter the challenges posed by competing theories and alternative models. The landscape of theoretical physics is rich and diverse, filled with ideas that challenge our understanding of reality. Some physicists argue that string theory, while promising, may not be the only pathway to a unified description of nature. The journey to uncover the true nature of our universe is complex and multifaceted, yet it is within this complexity that we find beauty. The interplay of ideas, the clash of theories, and the relentless pursuit of understanding form a vibrant tapestry, one that reflects the essence of scientific inquiry. As we embrace this journey, we are reminded that the quest for knowledge is not merely about finding answers. It is about the excitement of exploration, the thrill of discovery, and the profound realization that the universe is filled with mysteries waiting to be unveiled. String theory, with its promise of additional dimensions and the tantalizing notion of a multiverse, invites us to dream beyond the observable. It challenges us to envision a reality that transcends our limited experience, to imagine a cosmos teeming with possibilities. As we continue to navigate this landscape, we remain hopeful that the future will bring new revelations, perhaps illuminating the hidden dimensions and the strings that bind the universe together. Each question we ask propels us forward, urging us to seek deeper understanding, to explore the very fabric of existence itself. The pursuit of knowledge is a journey marked by curiosity and wonder, and string theory stands as a testament to the human spirit's relentless quest for understanding. As we ponder the mysteries of the universe, let us carry with us the spirit of exploration, ever eager to uncover the secrets that lie beyond the observable. The exploration of string theory and its implications for additional dimensions leads us to a fascinating intersection of ideas that further enrich our understanding of the cosmos. As we consider these extra dimensions, one cannot help but ponder how they might influence the very fabric of our universe. Could the hidden dimensions serve as conduits for forces we have yet to discover? Might they provide explanations for phenomena like dark matter and dark energy, those elusive entities that make up a substantial portion of our universe yet remain shrouded in mystery? Imagine the universe as a grand symphony, where each instrument represents a different force or particle. The hidden dimensions, then, could be the subtle harmonies that enhance the melody, shaping the interactions between these instruments in ways that are not immediately apparent to our senses. This notion was echoed by physicists like Nima Arkani Hamed, who has suggested that the extra dimensions might hold the key to unraveling the mysteries of gravity and its relationship with the other fundamental forces in nature. As we delve deeper into the implications of string theory, we encounter the notion of brain-world scenarios. In these models, our familiar universe may exist on a three-dimensional surface, known as a brain, floating in a higher dimensional space. Picture this brain as a shimmering sheet of fabric suspended in a vast, unseen expanse. The forces that we experience, such as gravity, could behave differently in this higher dimensional space, leading to intriguing possibilities for understanding cosmic phenomena. Contemplating these ideas encourages us to ask questions about the very nature of reality. What if the limitations we perceive are simply the result of our dimensional constraints? If gravity can extend beyond our brain while other forces remain confined, what implications does that have for our understanding of black holes or the behavior of particles at high energies? The interplay between string theory and brain-world scenarios opens up a treasure trove of questions that beckon us to explore further. The connection between string theory and the concept of a multiverse adds another layer of complexity to our understanding. Each configuration of extra dimensions could give rise to distinct universes, each with its own set of physical laws, much like different musical compositions derived from the same set of notes. This tantalizing idea leads us to consider the implications for our existence. Are we simply one of countless iterations, each universe a unique expression of the same fundamental principles? As we navigate these intricate concepts, the words of physicist Leonard Susskind remind us of the infinite possibilities that lie within this framework. The universe is not only queerer than we suppose, but queerer than we can suppose. This perspective encourages us to embrace the unknown, to marvel at the complexities that challenge our understanding, and to remain open to the astonishing potential of scientific discovery. Yet, despite the allure of string theory and its expansive vision of reality, the road ahead is not without obstacles. The challenges facing string theory research are significant, leading to debates within the scientific community about its validity and applicability. Critics argue that the theory lacks testable predictions, leaving it in a realm of speculation. This raises an important question. How do we advance our understanding when direct empirical evidence is so elusive? In response, researchers are actively seeking ways to bridge the gap between theory and experiment. Some physicists are exploring high-energy collisions at particle accelerators, hoping to uncover signs of string-like behavior or higher-dimensional interactions. Others are investigating the potential for gravitational waves to offer insights into the behavior of strings at cosmic scales. As we ponder these efforts, we can appreciate the resilience and creativity of the scientific endeavor, where every challenge becomes an opportunity for innovation. As we reflect on the current status of string theory, it is essential to recognize that the journey is as significant as the destination. The pursuit of knowledge, the engagement with profound questions, and the exploration of new ideas enrich our understanding of the universe. The interplay between skepticism and curiosity drives the scientific process forward, reminding us that every question we ask can lead to new avenues of exploration. In the grand tapestry of science, string theory serves as a vibrant thread, weaving together ideas of dimensions, multiverses, and the fundamental structure of reality. It invites us to explore the unknown, to embrace the mysteries that beckon from beyond our observable universe. As we stand on the threshold of discovery, we are reminded that the essence of science lies not only in the answers we seek, but in the wonder and excitement of the journey itself. Chapter 7. Observational Evidence. Testing Multiverse Theories. In the quest to understand the cosmos, astronomers employ a variety of methods to gather evidence that could illuminate the mysteries of the universe and the intriguing concept of the multiverse. These methods range from the observation of distant celestial bodies to the analysis of cosmic phenomena that ripple through the fabric of space-time. Picture astronomers as cosmic detectives, piecing together clues from the vastness of space to form a coherent narrative about our existence. One of the most profound tools at their disposal is the telescope. With its ability to capture light from stars and galaxies millions of light years away, the telescope serves as a gateway to the universe. Imagine the thrill of observing a distant galaxy, its light having traveled through the darkness of space for eons to reach our eager eyes. Each observation is a snapshot of the past, revealing not only the beauty of the cosmos, but also the intricate processes that govern its evolution. In addition to optical telescopes, astronomers utilize radio telescopes, which can detect radio waves emitted by celestial objects, unveiling phenomena invisible to the naked eye. Among the most compelling evidence gathered through these observational techniques is the cosmic microwave background radiation. This remnant glow, a whisper of the Big Bang, permeates the universe. Envision a sea of warmth that envelops the cosmos, a gentle echo of the moment when the universe began to cool and expand. The cosmic microwave background acts as a cosmic fingerprint, providing insights into the early universe's conditions. In analyzing its uniformity and slight fluctuations, scientists can infer critical information about the universe's age, composition, and the possible existence of other universes. The implications of this radiation extend beyond merely confirming the Big Bang. They also serve as fertile ground for multiverse theories. The slightly uneven distribution of temperature in the cosmic microwave background suggests that different regions of space may have evolved differently, potentially giving rise to distinct universes with varying physical laws. Imagine each fluctuation as a window into another universe, each with its own unique properties and possibilities. Gravitational waves, ripples in space-time produced by cataclysmic events such as colliding black holes or neutron stars, represent another powerful avenue for exploring multiverse theories. These waves travel across the universe, carrying with them information about their origins. When the LIGO Observatory detected the first gravitational waves, it was akin to hearing a whisper from the universe, a message from the depths of space-time. This discovery has opened new horizons in astrophysics, allowing us to probe the very fabric of reality. As we contemplate the significance of gravitational waves, we might wonder, what secrets do these ripples hold? They provide a unique perspective on the dynamics of the universe, offering insights into phenomena that are otherwise hidden from our view. In doing so, they also raise questions about the nature of existence itself. If gravitational waves can inform us about events in our universe, could they also hint at interactions with other universes? The possibilities stretch our imagination, inviting us to consider how interconnected our reality may be with realms beyond our comprehension. However, as we venture into this exciting territory, it is essential to recognize the limitations of our current observational techniques. The vastness of space presents significant challenges. Our instruments can only peer so far into the cosmos. The observable universe, while immense, is but a fraction of what may exist. Imagine standing on a beach, gazing at the ocean, aware that beyond the horizon lies a world yet unseen. The limitations of our technology mirror this horizon, reminding us that much remains undiscovered, even as we strive to expand our understanding. Moreover, the complexity of phenomena we seek to observe complicates our quest. Some events, such as the formation of the earliest galaxies or the interactions between dark matter and dark energy, occur on timescales that far exceed human experience. We may ask ourselves, how can we capture the fleeting moments of cosmic history? The answer lies in patience and innovation. Scientists are continually developing more sophisticated instruments, like next-generation space telescopes and advanced gravitational wave detectors, that promise to push the boundaries of our observational capabilities. As we consider these methods and the evidence they yield, it becomes clear that the universe is a vast, intricate puzzle, with each piece representing a new discovery. Each advancement in our observational techniques not only brings us closer to understanding our own universe, but also raises profound questions about the nature of reality. Are we alone, or do other universes exist, each with its own unique story? The pursuit of these answers invites us to ponder our place in the cosmos and the mysteries that lie just beyond our reach. In this expedition through the cosmos, the evidence we gather paints a picture that is both beautiful and complex. Cosmic microwave background radiation and gravitational waves provide tantalizing glimpses into the workings of our universe, while also hinting at worlds we have yet to explore. As we continue to refine our understanding, we embark on a journey that transcends the boundaries of our own universe, inviting us to dream of the infinite possibilities that lie beyond. The methods astronomers employ to gather evidence extend beyond merely observing the heavens. They engage in a relentless pursuit of knowledge, utilizing advanced technologies and techniques that allow them to probe deeper into the universe's mysteries. One such method is the study of gravitational lensing, where the light from distant objects bends around massive structures, such as galaxies or dark matter, creating a cosmic magnifying glass. Imagine gazing through a lens that reveals not just the distant light of stars, but also hidden galaxies that would otherwise remain invisible. This phenomenon enables astronomers to map the distribution of dark matter and gain insights into the universe's expansion, weaving a narrative that connects the visible with the invisible. As we consider the cosmic microwave background radiation, we must recognize its role as a time capsule, offering a glimpse into the universe's infancy. The slightly uneven temperature variations detected across this radiation serve as a canvas upon which the early universe's density fluctuations are painted. These fluctuations, akin to ripples on a pond, inform our understanding of how galaxies formed and evolved over billions of years. They can even hint at the existence of other universes, suggesting that regions of space could have different properties, leading to a plethora of realities intertwined within the grand cosmic framework. Gravitational waves, those subtle ripples in space-time, invite us to explore yet another layer of the universe's tapestry. When two massive objects collide, such as black holes merging, they send shock waves through the fabric of space-time, which we can detect with astonishing precision. These waves carry with them a wealth of information about the events that created them. Picture a serene lake disturbed by a falling stone. The ripples expand outward, revealing the impact of that singular event. Similarly, gravitational waves allow us to witness the echoes of cosmic events, providing a new way to observe phenomena that were previously undetectable. As we delve further into the implications of these discoveries, we can appreciate how they challenge our understanding of reality. The prospect that gravitational waves might offer insights into interactions between our universe and others is both thrilling and humbling. What does it mean for our understanding of causality if events in one universe can influence another? The fabric of reality, it seems, is woven with threads that transcend our immediate experience. However, the journey into understanding the multiverse is not without its challenges. The limitations of our current observational techniques remind us of the vastness of what lies beyond our grasp. Our telescopes and detectors, while marvels of human ingenuity, can only explore so far into the cosmic ocean. The universe is expanding, and light from distant galaxies is redshifted, making it more challenging to gather information from the edges of our observable universe. This expansion is akin to watching a distant ship sail away, its details fading into the horizon, just as many celestial phenomena elude our detection. Moreover, the scale of time involved in cosmic events can be daunting. The birth and death of stars, the formation of galaxies, and the interactions of dark matter all unfold over timescales that dwarf human experience. This leads us to ponder: how can we capture the essence of events that span eons? The answer lies in the synthesis of new technologies and methodologies that push the boundaries of our observational capabilities. As we gaze into the future, we can envision advanced observatories and space missions designed to unlock the secrets of the universe, like cosmic archaeologists unearthing the remnants of time. Consider the potential that exists in the future of observational astronomy. With advancements in technology, such as the development of next-generation space telescopes, we may uncover details about the early universe that have remained hidden. These telescopes will enable us to observe the faint light from the first stars and galaxies, illuminating the epochs of cosmic history that shaped our universe. Each discovery will bring us closer to understanding the intricate processes that govern the cosmos, while also expanding our comprehension of multiverse theories. As we tread this path of exploration, we must also acknowledge the philosophical implications of our findings. What does it mean for humanity to confront the possibility of multiple universes, each with its own set of physical laws? This tantalizing idea invites us to reflect on our existence, our beliefs, and our understanding of reality itself. The multiverse concept challenges the very notion of uniqueness, urging us to consider that our universe might be but one of countless others, each a unique tapestry of existence. In this expansive narrative, the evidence we gather acts as a guiding light, illuminating the shadows of the unknown. The cosmic microwave background radiation and gravitational waves serve as bridges to deeper understanding, connecting us to the very origins of the universe and the potential for parallel realities. As we refine our observational techniques and push the boundaries of our understanding, we embark on a journey that weaves together science, philosophy, and the essence of human curiosity. The pursuit of knowledge in the realm of the multiverse is a testament to the human spirit's unyielding desire to understand the cosmos. Each small discovery propels us forward, revealing the interconnectedness of all things and inviting us to dream of the infinite possibilities that lie beyond. As we continue this cosmic odyssey, we remain ever hopeful that the mysteries of the multiverse will one day reveal themselves, enriching our understanding of existence and our place within the grand scheme of the universe. As we explore the limitations of our observational techniques, we must also acknowledge the role of theoretical frameworks that guide our understanding. These frameworks, like the scaffolding of a grand edifice, provide a structure upon which our observations are built. They help us interpret the data we gather and connect the dots of our cosmic puzzle. For instance, the principles of quantum mechanics and the theories surrounding cosmic inflation challenge our perceptions of time and space, urging us to consider that our observations might only scratch the surface of a much deeper reality. The quest for evidence of the multiverse also raises questions about the nature of scientific inquiry itself. What does it mean to search for something that may be inherently unobservable? This dilemma forces us to consider the criteria by which we define scientific evidence. Can we truly call ourselves explorers of the universe if we are limited to the observable? The very notion of a multiverse suggests realms beyond our reach, prompting us to ask, how do we validate theories that lie outside the confines of direct observation? One approach to bridging this gap is through indirect evidence. Scientists often rely on the data collected from cosmic phenomena that suggest the existence of other universes. For instance, certain models of inflationary cosmology predict the existence of pocket or bubble universes that arose from quantum fluctuations during the rapid expansion phase. These predictions can be tested through their implications on cosmic structures, providing a tantalizing glimpse into the possibility of a multiverse. Imagine the universe as a vast orchard, with each tree representing a different universe, each bearing its own unique fruit, some ripe with familiar shapes, others strange and unfamiliar. In addition to indirect evidence, the pursuit of technological advancements continues to enhance our observational capabilities. Innovations such as gravitational wave detectors and space-based telescopes hold the promise of unveiling mysteries previously hidden from our view. These advancements not only refine our existing knowledge, but also open new avenues for exploration. As we prepare for future missions, we can envision a time when the boundaries of our observational realm expand, allowing us to probe the cosmos with unprecedented clarity. The expansion of our observational techniques is akin to equipping ourselves with a more powerful lens through which to view the universe. Each new instrument developed serves as a tool to enhance our understanding, enabling us to peer deeper into the cosmic abyss. Just as early astronomers marveled at the stars through their rudimentary telescopes, we stand on the brink of a new era, where advanced technologies may bring forth revelations that could reshape our understanding of reality itself. Yet, as we push forward in our quest for knowledge, we must also remain grounded in humility. The universe, in all its complexity, often defies our attempts to confine it within rigid frameworks. We are reminded of the words of physicist Richard Feynman, who famously said, "The principles of science are not the principles of the universe." This sentiment encapsulates the essence of our journey into the multiverse. The understanding that what we observe is but a fragment of a larger, enigmatic whole. As we continue to gather evidence and develop theories, we may find ourselves faced with the profound realization that our universe may be but one of many. This notion challenges our understanding of identity, existence, and the very nature of reality. How does one define uniqueness in a cosmos where multiple realms coexist? The implications are staggering, inviting us to ponder the essence of our own universe in relation to others yet unseen. Thus, the exploration of multiverse theories is not merely a scientific endeavor. It is a philosophical journey that compels us to confront the limitations of human understanding. Each piece of evidence we uncover serves as a stepping stone toward greater revelations. Yet, it also reminds us of the vast unknown that lies ahead. As we stand at the threshold of discovery, we are called to embrace the uncertainty and complexity of our universe, welcoming the questions that propel us forward. Through our gathering of observational evidence, we begin to weave a narrative that transcends the boundaries of our own existence. The cosmic microwave background radiation and gravitational waves serve as conduits to understanding, revealing whispers of the universe's history and hinting at the existence of realms beyond our perception. As we refine our methods and embrace the challenges of exploration, we embark on a journey that may one day illuminate the profound interconnectedness of all realities, each a unique expression of existence within the grand cosmic dance. Chapter 8. The Philosophical Implications of Multiple Universes. The notion of multiple universes presents a profound challenge to our traditional views of existence, fundamentally reshaping our understanding of reality. Imagine, if you will, the implications of a cosmos that is not a singular entity, but rather a vast collection of universes, each with its own unique characteristics, laws, and outcomes. The multiverse concept invites us to reconsider the very nature of existence itself. What does it mean to be alive in a universe that is but one of many? How would our understanding of choice and destiny change if every decision we make spawns new realities? Philosophers and scientists alike have grappled with these questions, often drawing upon the insights of those who have ventured into the depths of theoretical exploration. Take, for instance, the words of the physicist Max Tegmark, who articulated the idea that the universe is not just what we see, but also what we can imagine. This perspective encourages us to expand our horizons, to think beyond the limitations of our observable universe, and consider a reality where every possibility is played out in parallel dimensions. As we explore these philosophical implications, we encounter ethical considerations that arise within a multiverse context. If every conceivable action leads to the creation of a new universe, how do we navigate the moral landscape of our decisions? Imagine a scenario where a choice made in one universe results in vastly different outcomes in another. Does this diminish the significance of our choices, or does it enhance our responsibility to consider the ramifications of our actions on a grander scale? The ethical dilemmas multiply in a multiverse. How do we weigh the consequences of our actions when they resonate across countless realities? Should we act with the understanding that in some universe, our choices lead to suffering, while in another, they result in profound joy? This interplay of morality and existence invites us to reflect deeply on the nature of free will. Are we truly autonomous beings, or are we merely players in a cosmic game where every move has infinite consequences? The role of consciousness further complicates this tapestry of existence. What if our awareness itself influences the selection of which universe we inhabit? Picture the idea that our thoughts and intentions might shape the very fabric of reality, guiding us towards certain outcomes while veering us away from others. This concept aligns with the interpretations of quantum mechanics, where the observer plays a crucial role in determining the state of a system. Could it be that our collective consciousness acts as a selector, choosing which of the multiverse's myriad paths we experience? Philosophers such as David Deutsch have posited that the multiverse is a more fundamental reality than the universe we think we know. This suggests that consciousness and existence are intertwined in a way that transcends our current understanding. The very act of observation may not only reveal but also create the realities we inhabit. Imagine a universe where every thought, every intention resonates across dimensions, weaving a complex web of interconnected experiences. Debates among philosophers and scientists continue to flourish as they explore these captivating questions. Some assert that the multiverse is a mere theoretical construct, a tantalizing idea with little grounding in empirical evidence. Others argue that its implications are too profound to ignore, urging us to embrace the uncertainty and wonder that comes with such a paradigm shift. The writings of notable figures like Albert Einstein remind us that, quote, reality is merely an illusion, albeit a very persistent one. In this light, the multiverse becomes not just a scientific hypothesis, but a philosophical inquiry into the nature of existence itself. Consider the implications of a universe where every potential outcome exists simultaneously. What does it mean for our understanding of success and failure? In one universe, you might be a celebrated composer, while in another, you may never have picked up an instrument. The weight of these possibilities can be overwhelming yet liberating. It invites us to ponder the essence of identity and the factors that shape who we are. Are we defined by our choices, or merely the sum of our experiences across countless realities? The philosophical implications of multiverses extend to the very core of human experience. They challenge us to reflect on our values, our beliefs, and the essence of what it means to live a meaningful life. If our existence is but one thread in a vast fabric, how do we find purpose? Perhaps it lies in the connections we forge, the kindness we extend, and the love we share. Each of these actions resonates not only in our universe, but also in the countless others that spring forth from our choices. As we ponder these concepts, let us not forget the beauty that lies in the unknown. The multiverse offers a canvas rich with potential, a space where imagination and reality intertwine. It beckons us to embrace uncertainty, to find solace in the mysteries that lie beyond our current understanding. What if the very act of contemplating these ideas opens doors to new realms of possibility? In the quiet moments of reflection, we might find that the philosophical implications of multiple universes offer not just challenges, but profound insights into our existence. They remind us that we are part of something far grander than ourselves, a cosmic journey that transcends time and space. The universe, with all its wonders and intricacies, invites us to explore, to question, and ultimately, to connect with the vastness that surrounds us. As we continue to explore the philosophical implications of multiple universes, we are left with an awe-inspiring tapestry of existence that challenges our perceptions, encourages ethical reflections, and invites us to consider the power of consciousness in shaping our reality. Through this exploration, we open ourselves to a deeper understanding of our place within the cosmos, revealing the interconnectedness of all things in a multiverse that is as profound as it is mysterious. The exploration of ethical considerations within a multiverse context unveils a complex landscape where the weight of our choices resonates far beyond the confines of a single reality. Each decision we make could be seen as a pebble cast into an expansive lake, sending ripples that affect not just our universe, but countless others. The question of moral responsibility thus becomes intricately tied to the fabric of existence itself. How do we reconcile our actions with the knowledge that they may have profound consequences in alternate realities? Consider the words of philosopher Philip K. Dick, who mused, "Reality is that which, when you stop believing in it, doesn't go away." In a multiverse, this notion takes on new meaning. Our beliefs and intentions may not only shape our personal universe, but may also echo through the myriad of parallel existences. Each choice we make could lead to a multitude of outcomes, each deserving of ethical consideration. If we accept that every possible action manifests in some universe, does this not compel us to live with a greater awareness of the implications of our choices? Imagine a world where compassion is a guiding principle, not just for oneself, but for the infinite versions of ourselves scattered across the multiverse. This perspective encourages a deeper sense of empathy, as we recognize that our struggles and triumphs are mirrored in alternate realities. If our actions can lead to suffering in one universe while fostering joy in another, how do we navigate the moral labyrinth of existence? The potential for interconnectedness across countless realities could inspire a more profound sense of collective responsibility. The role of consciousness in this grand tapestry cannot be overstated. It beckons us to consider whether our awareness serves as a lens through which we select our realities. If consciousness influences the path we traverse within the multiverse, could it be that our thoughts and emotions act as guiding stars, illuminating the way towards certain experiences while obscuring others? This notion evokes the interpretations found within quantum mechanics, where the observer's role is pivotal in shaping the outcomes of experiments. As we delve into this idea, we might ask ourselves, are we the architects of our realities, or are we merely observers swept along by the currents of fate? The interplay between consciousness and existence invites a captivating inquiry into the nature of free will. Imagine if our intentions could reach across dimensions, creating a ripple effect that alters not only our own universe, but also influences the countless others that share the multiverse with us. This concept aligns with the philosophical musings of figures like Henry James, who once asserted that we are all the sum of our experiences. In the context of the multiverse, this statement takes on a new dimension. Our experiences, shaped by our decisions, ambitions, and dreams, reverberate throughout a vast network of realities. Each version of ourselves in alternate universes grapples with its own set of experiences, yet they are all interconnected by the choices we make in this singular existence. Philosophical debates surrounding these ideas flourish among scholars and thinkers. Some argue that the multiverse is merely a theoretical abstraction, lacking the empirical backing to warrant serious consideration. Others, however, contend that the implications of such a framework are too critical to dismiss. The challenge lies in reconciling the abstract with the tangible, seeking a way to bridge the gap between theoretical possibilities and lived experiences. What if we view the multiverse not just as a series of parallel realities, but as a profound commentary on the nature of existence? Each universe within the multiverse invites us to explore alternative paths and outcomes, offering a rich tapestry of existence that reflects our deepest aspirations and fears. This interconnectedness fosters a sense of belonging to something greater than ourselves, a cosmic family bound not only by the choices we make, but also by the shared humanity that transcends the boundaries of individual realities. The philosophical implications of multiple universes also raise questions about identity and self. If we exist in countless iterations across a spectrum of realities, how do we define who we are? Are we the sum of our choices in this universe, or do we encompass the vast array of experiences across the multiverse? Imagine standing in front of a mirror that reflects not just your image, but a multitude of versions of yourself, each shaped by different decisions and circumstances. This visualization challenges our understanding of identity and prompts us to consider the fluidity of selfhood. As we continue to grapple with these profound questions, we find that the multiverse serves as both a scientific hypothesis and a philosophical lens through which to examine our own lives. The interplay between existence, choice, and consciousness invites us to reflect on our values and beliefs in a way that transcends the ordinary. It encourages us to embrace the unknown, to find beauty in uncertainty, and to seek connections that bind us across the infinite expanse of realities. In this exploration, we glimpse a universe rich with potential, a mosaic of experiences waiting to be uncovered. Each thought, each intention, has the power to shape our reality and those that lie beyond. The multiverse is not merely a theoretical construct, it is an invitation to ponder the nature of existence itself. It beckons us to embrace the wonder of possibility and to recognize our place within the grand cosmic narrative that unfolds across dimensions. As we reflect on the philosophical implications of the multiverse, we find ourselves at a crossroads of thought and feeling. The journey through these concepts invites us to consider our role in the vast tapestry of existence, leading us to a deeper understanding of what it means to be alive in a universe that is but one of many. Chapter 9. Cultural Representations of the Multiverse. In the realm of storytelling, the multiverse has found a captivating presence in both literature and film, weaving a spell of wonder that transcends our conventional understanding of reality. Imagine diving into a narrative where the boundaries of existence are stretched like an elastic band, revealing worlds that coexist alongside our own. From the pages of classic novels to the flickering screens of modern cinema, the concept of alternate realities invites us to explore the infinite possibilities that lie beyond our singular experience. Consider the profound influence of works like Jorge Luis Borges' The Garden of Forking Paths, where the narrative itself becomes a labyrinth of choices and consequences. Borges presents a universe where every decision spawns a branch of reality, leading to countless divergent paths. This exploration of alternate outcomes resonates deeply with the philosophical inquiries surrounding the multiverse. What if our lives are not linear, but rather a series of interconnected threads, each one representing a different choice? In film, the multiverse concept has garnered significant attention, particularly in recent years. Consider the animated film, Spider-Man Into the Spider-Verse, which introduces audiences to a vibrant tapestry of alternate Spider-People, each hailing from their own unique universe. This film not only entertains, but also serves as a visual representation of the multiverse theory, illustrating how different realities can intersect and influence one another. The vibrant colors and dynamic animation invite viewers to imagine the myriad forms existence can take, sparking a sense of wonder that lingers long after the credits roll. Across various cultures, perceptions of alternate realities reveal a rich tapestry of beliefs and narratives. In many indigenous cultures, for instance, there exists a deep understanding of the interconnectedness of all things, often represented through stories that transcend time and space. These narratives invite us to consider the existence of multiple realities, where the past, present, and future intertwine in a cosmic dance. Similarly, in Eastern philosophies, the concept of multiple existences is often embraced. The idea of reincarnation, prevalent in Hinduism and Buddhism, suggests that life is a continuous cycle, with each existence offering a new opportunity for growth and learning. This perspective aligns closely with the multiverse theory, where each life can be seen as a unique thread in the grand fabric of reality, weaving a narrative that is both complex and beautiful. The impact of science fiction on public understanding of these concepts cannot be overstated. Through imaginative storytelling, science fiction has the power to shape our perceptions of reality, expanding our minds to embrace ideas once thought to be mere fantasy. Works such as Philip K. Dick's stories often delve into the nature of reality, blurring the lines between what is real and what is imagined. As Dick famously stated, reality is that which, when you stop believing in it, doesn't go away. This sentiment captures the essence of the multiverse, suggesting that our beliefs and perceptions play a crucial role in shaping our understanding of existence. Popular multiverse narratives often serve as a mirror, reflecting our deepest hopes, fears, and questions about reality. In the television series Rick and Morty, for example, the characters traverse a multitude of universes, each with its own peculiarities and challenges. This exploration is not merely for comedic effect, but also prompts viewers to consider the implications of their choices and the nature of their existence. What if every decision creates a new reality? How would that shape our understanding of free will and responsibility? In the realm of literature, Neil Gaiman's The Sandman series invites readers to traverse the boundaries between dreams and reality, illustrating how our perceptions shape the worlds we inhabit. Gaiman's intricate storytelling encourages us to ponder the nature of existence itself, compelling us to question what lies beyond the veil of our perceived reality. As we analyze these popular multiverse narratives, we uncover a common thread that binds them together: the exploration of identity. In many stories, characters grapple with their sense of self in the face of alternate realities. They confront parallel versions of themselves, prompting profound questions about the nature of individuality. Are we defined solely by our choices? Or is there a deeper essence that transcends the multitude of possibilities? In the realm of science fiction, the multiverse serves as a fertile ground for exploring these themes. As audiences engage with these narratives, they are invited to reflect on their own lives and the choices that shape their realities. Through the lens of the multiverse, we can view our existence as a grand experiment filled with infinite potential and possibilities. The concept of the multiverse not only captivates our imaginations, but also offers a framework for understanding the complexities of existence. As we traverse the landscapes of literature and film, we find ourselves confronted with questions that challenge our perceptions of reality. What if our lives are merely one thread in a vast, interconnected web of existence? How does the exploration of alternate realities enrich our understanding of who we are? In embarking on this journey through cultural representations of the multiverse, we are reminded of the power of storytelling to inspire curiosity and wonder. Each narrative invites us to step outside the confines of our own reality, urging us to explore the infinite possibilities that lie within and beyond. The multiverse, in all its complexity, beckons us to embrace the unknown and to find beauty in the myriad forms existence can take. As we reflect on the impact of these narratives, we recognize the significance of imagination in shaping our understanding of the cosmos. Through literature and film, we can explore the nature of reality in ways that resonate with our deepest questions and aspirations. The multiverse concept allows us to envision a reality that is not fixed, but rather a fluid tapestry of possibilities, urging us to consider our place within this expansive cosmos. With each story, we are invited to envision a universe where the extraordinary can flourish, where alternate realities coalesce, and where the boundaries of existence are merely the beginning of a grand adventure. The multiverse serves as a canvas upon which we can paint our dreams, fears, and hopes, reminding us of the richness of life itself. What stories await us as we continue to explore this uncharted territory? What revelations lie just beyond the horizon? The answers may be as boundless as the multiverse itself. As we immerse ourselves in these cultural representations, we find comfort in the knowledge that our curiosity is a bridge to understanding. Each narrative we encounter serves as a reminder of our shared humanity, urging us to explore the depths of possibility and connection that lie within the multiverse. In this journey, we discover that we are not alone. We are part of a larger story, woven together by the threads of imagination and inquiry. Together we stand on the precipice of understanding, gazing into the vastness of the multiverse, ready to embrace the mysteries that await us. In this exploration, we learn that the journey is just as important as the destination, and that each step we take brings us closer to the heart of existence itself. The multiverse concept has not only influenced literature and film, but has also sparked compelling discussions about the nature of existence itself. In the realm of storytelling, we often find ourselves drawn to narratives that push the boundaries of our understanding. Through these tales, we engage in a collective exploration of identity, fate, and the choices that shape our lives. Consider the ways in which different cultures have interpreted the idea of alternate realities. In many indigenous mythologies, creation stories often encompass multiple realms, each inhabited by distinct beings and governed by different laws. These narratives serve not only as a means of explaining the cosmos, but also as a profound reflection of the interconnectedness of all life. Imagine a world where the spiritual and the material coexist, where the boundaries between realms are fluid, and where the actions of one being ripple across the fabric of existence. Such perspectives resonate deeply with the multiverse theory, inviting us to contemplate the nature of reality as a tapestry of interwoven lives and experiences. In contrast, Western philosophies have traditionally leaned towards a more linear understanding of existence. However, as the multiverse concept gains traction in popular culture, we are beginning to see a shift in this perspective. The portrayal of alternative realities in contemporary literature and film not only entertains but also encourages viewers to question their own beliefs about destiny and choice. How often do we find ourselves pondering the roads not taken, the paths that diverged before us? Through the lens of the multiverse, these reflections take on a new depth, as we are invited to consider the possibility that each choice creates a branching reality, with its own unique consequences. As we engage with these narratives, it is essential to recognize the role of science fiction in shaping public understanding of complex scientific concepts. The imaginative worlds crafted by authors and filmmakers serve as a bridge between abstract theories and the human experience. In the works of authors like Isaac Asimov and Arthur C. Clarke, we see the multiverse not merely as a theoretical construct, but as a framework for exploring the ethical and moral implications of advanced technology and human evolution. The narrative possibilities are limitless, inviting us to ponder the responsibilities that come with such profound knowledge. Take, for instance, the film Everything Everywhere All at Once, which dives into the intricacies of a multiverse where infinite potential exists. The protagonist, grappling with her mundane life, suddenly finds herself entangled in a vast array of alternate realities. This film artfully illustrates how our choices, even the seemingly trivial ones, can shape not only our personal trajectories but also the fates of countless others. It poses the question, what does it mean to live fully in a world where every possibility exists? This exploration extends into the realm of identity, where characters confront alternate versions of themselves. In narratives like The One, we witness the consequences of a character's actions across various realities, leading to a profound understanding of self. The confrontation with alternate selves prompts introspection, urging audiences to consider the essence of individuality. Are we merely products of our environment and choices, or is there an intrinsic self that transcends the multiverse? As we reflect on the impact of these narratives, we also uncover the ways in which they resonate with our collective consciousness. Stories of alternate realities allow us to grapple with our fears and aspirations, offering a safe space to explore the unknown. They serve as a reminder of the limitless potential that lies within us, urging us to embrace the complexities of existence and the myriad paths we can take. In this context, it becomes evident that the cultural representations of the multiverse are more than mere entertainment. They are a reflection of our shared human experience. The multiverse serves as a metaphor for the choices we face daily, the diverging paths that lead to different outcomes. Each story invites us to reflect on our own lives, to consider the myriad possibilities that could arise from a single decision. What if we dared to explore the uncharted territories of our own potential? What if we embrace the uncertainty that comes with the knowledge that multiple realities exist, each waiting to be discovered? As we navigate the ever-expanding landscape of the multiverse in popular culture, we are reminded of the power of storytelling to inspire change. Each narrative, whether it be in a book, a film, or a conversation, holds the potential to shift our understanding and challenge our perceptions. The multiverse concept encourages us to look beyond the confines of our own experiences, inviting us to empathize with the lives of others, even those from alternate realities. In the end, the exploration of cultural representations of the multiverse offers a rich tapestry of insights and reflections, reminding us that our understanding of existence is not fixed. As we continue to engage with these narratives, we find ourselves on a journey that transcends the boundaries of our individual lives, connecting us to a larger cosmic narrative. What new revelations await us as we delve into the multiverse's infinite possibilities? How can we harness the lessons learned from these stories to enrich our understanding of ourselves and the world around us? With each tale, we are invited to embrace the unknown, to explore the depths of our imagination, and to celebrate the beauty of existence in all its forms. The multiverse, in its many manifestations, beckons us to continue our quest for understanding, reminding us that the journey itself is as significant as the destination. Chapter 10. Future Directions in Cosmology and Multiverse Research. As we stand at the precipice of a new era in cosmology, emerging theories and technologies promise to reshape our understanding of the universe in profound ways. Imagine a vast, unexplored frontier, where the latest scientific advancements are like bright beacons guiding us toward new realms of possibility. The rapid development of observational technologies, such as next-generation telescopes and advanced computational models, expands our ability to observe and analyze the cosmos beyond what we once deemed possible. Consider the James Webb Space Telescope, a marvel of engineering which has already begun to unveil the secrets of the early universe. With its ability to observe the faintest light from distant galaxies, it offers glimpses into cosmic epochs long past. Each image captured is not merely a photograph. It is a window into the very moments that shaped the universe. As we peer through this window, we are reminded of the words of physicist Neil deGrasse Tyson. The universe is under no obligation to make sense to you. This sentiment encapsulates the awe and wonder that science strives to decode, even as we grapple with the unfamiliar. Alongside these observational advancements, theoretical proposals continue to evolve, opening doors to new ideas about the nature of reality. Quantum gravity, for instance, seeks to unify general relativity with quantum mechanics, potentially leading to a deeper understanding of space-time itself. Picture a framework where the fabric of reality is not just a static entity, but a dynamic interplay of quantum states, where the universe is in a constant state of flux. What might this mean for our understanding of time and existence? As we ponder this, we are drawn to the potential for discoveries that could redefine the very essence of our cosmic narrative. The next decade holds the promise of remarkable breakthroughs as scientists around the globe collaborate in their quest to unravel the mysteries of the universe. Imagine a future where artificial intelligence assists in analyzing vast datasets, discerning patterns that elude human comprehension. This synergy between human intellect and machine learning could accelerate our pursuit of knowledge, leading to new theories and insights that challenge our existing paradigms. The implications are vast as we consider the possibility of uncovering new forms of matter or energy that have thus far remained hidden from our sight. As we venture into this future, the exploration of dark matter and dark energy stands at the forefront of cosmological research. These enigmatic components, which constitute much of the universe's mass energy content, have long eluded our understanding. Imagine a world where we finally unlock the secrets of dark matter, revealing its true nature and role in cosmic evolution. Such a discovery would not only illuminate the structure of the universe, but could also provide insights into the fundamental forces that govern it. Moreover, advancements in gravitational wave astronomy promise to enrich our understanding of cosmic events. The detection of these ripples in space-time, produced by the collision of massive celestial objects, heralds a new era in observational cosmology. Each gravitational wave event carries with it a treasure trove of information about the dynamics of the universe. Imagine the thrill of piecing together the story of a distant black hole merger, where the very fabric of space-time trembles in response to the cosmic ballet of these titanic entities. In parallel to these technological advancements, the philosophical questions surrounding our place in the universe continue to deepen. What does it mean to exist in a cosmos that may harbor countless other realities? This inquiry is not merely academic. It resonates with our fundamental sense of self. As we explore the notion of the multiverse, we are invited to reflect on our choices and existence. Could every decision we make give rise to a new universe, each path branching out into infinite possibilities? Such contemplation sparks a sense of wonder as we consider the interconnectedness of all things. This ongoing quest for answers about our cosmic existence is more than a scientific endeavor. It is a journey of the human spirit. As we seek to understand the cosmos, we are also searching for meaning, grappling with the profound questions that have echoed through the ages. The words of physicist Carl Sagan remind us of our place within this vast cosmos. We are made of star stuff. This poetic notion underscores the intimate connection between humanity and the universe. inviting us to explore our origins and the very essence of life itself. As our understanding deepens, we are challenged to broaden our perspectives and embrace the unknown. The future of cosmology may unveil truths that transcend our current understanding, leading us to confront the nature of reality in ways we have yet to imagine. With each new discovery, we are reminded of the vastness of the cosmos and our humble position within it. What awaits us in the coming years is an exciting tapestry of exploration, where each thread contributes to a greater understanding of the universe's mysteries. The interplay of emerging theories and cutting-edge technologies will guide us toward new horizons, illuminating the path for future generations of scientists, philosophers, and dreamers. As we stand on the threshold of these possibilities, it is essential to nurture our curiosity and embrace the uncertainties that lie ahead. Just as the ancients looked to the stars for guidance, we too must maintain our sense of wonder as we contemplate the vast expanse of the cosmos. Our journey is not merely about uncovering facts. It is about weaving a narrative that connects us to the universe in profound ways. In this ever-expanding quest, we are reminded that the universe is not a static entity but a living, breathing cosmos, bursting with potential and mystery. Each new discovery brings us closer to understanding the elegant dance of particles and forces that shape our reality. As we continue to explore, may we find solace in the knowledge that we are part of something far greater than ourselves, a grand experiment in existence that invites us to ponder our place within the cosmic symphony. The future of cosmology and multiverse research beckons with the promise of new insights and revelations. As we look forward, let us approach the unknown with open hearts and minds, embracing the wonder of discovery that lies ahead. The universe awaits our gaze, holding secrets yet to be unveiled, and the journey has only just begun. As we look toward the horizon of cosmological exploration, the potential for groundbreaking discoveries looms larger than ever. Advancements in technology are transforming our ability to probe the cosmos, bringing previously unattainable insights within our reach. Consider the power of gravitational lensing, a phenomenon where massive objects like galaxies bend the light from distant stars. This natural telescope allows astronomers to observe objects that would otherwise remain hidden, unveiling the structure of the universe and its hidden treasures. Each lensing event is not merely a cosmic accident. It serves as a reminder of the intricate connections that bind celestial bodies across vast expanses. Imagine the thrill of using this technique to study the distribution of dark matter. As we explore the universe, dark matter remains elusive, a ghostly presence that influences the motion of galaxies without ever revealing itself directly. By analyzing the light distorted by gravitational lensing, we can begin to map the unseen web of dark matter that shapes cosmic structures. What mysteries might this hidden component of the universe hold? The prospect of finally uncovering its properties could revolutionize our understanding of fundamental physics. Furthermore, the next decade may witness the rise of new observational techniques that harness the power of artificial intelligence. As machine learning becomes increasingly sophisticated, it could enhance our ability to analyze vast data sets collected from telescopes and experiments. Imagine algorithms trained to identify subtle patterns in cosmic microwave background radiation or to predict the behavior of distant exoplanets. This synergy between human insight and machine efficiency may accelerate our journey toward uncovering the secrets of the universe. The exploration of exoplanets, in particular, is a realm poised for significant advancements. As we refine our techniques for detecting and characterizing these distant worlds, the potential for discovering habitable conditions outside our solar system grows. Picture a planet orbiting a distant star where the conditions could mirror those of Earth. What forms of life might exist there, and how might they differ from our own? This tantalizing possibility invites us to ponder the implications of finding life beyond our planet, a moment that could reshape our understanding of biology and existence itself. As we venture deeper into this uncharted territory, the implications of multiverse theories could also intersect with the search for exoplanets. If our universe is merely one of many, what significance does the discovery of life in another universe hold? Might it contribute to a broader understanding of existence that transcends our singular narrative? The exploration of these questions fuels the imagination, driving scientists and philosophers alike to contemplate the interconnectedness of all life across multiple realms. In tandem with technological innovations, the pursuit of a unified theory of physics remains a guiding light in cosmology. The desire to reconcile general relativity and quantum mechanics is not merely an academic challenge, it is a quest that could illuminate the very foundations of reality itself. Imagine a world where the forces that govern the cosmos are woven together into a single, elegant framework. This pursuit has captured the minds of many, including the late Stephen Hawking, who famously said, "When we understand how the universe began, we will know how to make predictions about the future." This relentless quest for knowledge motivates scientists to push the boundaries of our understanding, seeking insights that could redefine our relationship with the universe. The implications of these advances extend beyond mere scientific curiosity. They resonate with our innate desire for meaning. As we unravel the complexities of the cosmos, we reflect upon our own existence and the stories we tell ourselves about who we are. The journey through cosmology is not just about understanding celestial mechanics. It is about grappling with our place within the grand narrative of the universe. What does it mean to be a part of something so vast and intricate? These reflections invite us to ponder our interconnectedness with the cosmos, evoking a sense of wonder that transcends the confines of our everyday lives. Moreover, as we explore the multiverse, we encounter the notion that our universe might be just one of many, each with its own set of physical laws and histories. Imagine worlds where the constants of nature differ from those in our own, leading to entirely distinct forms of life and consciousness. This concept evokes a sense of humility, reminding us that our understanding of reality is limited by our experiences and perceptions. The philosophical implications ripple through our collective consciousness, prompting us to consider the nature of existence in a multifaceted cosmic landscape. As we continue to forge ahead, the quest for answers about our cosmic existence remains a driving force in cosmology. Each step forward, whether through technological innovation or theoretical exploration, brings us closer to unlocking the mysteries that have captivated humanity for millennia. The universe, with all its complexity and beauty, invites us to embrace the unknown and remain open to the possibilities that lie ahead. In this ongoing journey, we must nurture our curiosity and inspire future generations to look to the stars with wonder. The pursuit of knowledge is a shared human endeavor, one that transcends borders and cultures. As we strive to understand the cosmos, may we also cultivate a sense of reverence for the mysteries that remain, recognizing that the journey itself is just as important as the destination. The future of cosmology and multiverse research stands as a testament to humanity's quest for understanding. Armed with new tools, theories, and a spirit of exploration, we are poised to embark on a new chapter in our cosmic narrative. Each discovery will not only enhance our knowledge, but will also deepen our connection to the universe, reminding us that we are part of a grand tapestry woven from the very fabric of existence. What lies ahead in this remarkable journey is a horizon filled with potential, a canvas waiting for the brushstrokes of discovery that will shape our understanding of the cosmos for generations to come.